Now we look at example 2. So in example 2, the highlight here is find the value of k using the definition of continuity. For example 1, we are using the definition of limits. So now we look at example 2. Let hx is a piecewise function. So again, this is a piecewise function. Determine whether hx is continuous at x is equals to 0. B. Find the value of k such that hx is continuous at x is equals to 2. So first we have to determine whether it's continuous at x is equals to a. Like the previous example, it is better that we start with a real number line. So means that here we have 0 and 2. So here we have 0 and 2. So for the function, when x is less than 0, the function is x. So when x is less than 0 means that it's the left hand side, the function is x. When x is greater or equals to 0 but less than or equals to 2, the function is 2x squared. So means that here is 2x squared. When x is greater than 2, the function is negative 2x plus k. Negative 2x plus k. So now we start to answer question A. Determine whether hx is continuous at x is equals to 0. So here is x is equals to 0. So the first condition, f0. Again, we try to identify 0 located either is in the first interval or the second interval. You can see that in the second interval, this symbol means that it's included 0. So we will choose the second function. So from here, I should have 2, 0 squared. So here is 0. Now comes to the second condition. Limit. When x, we will try to find the left hand limit and right hand limit. X approach 0 from the left hand side. So here is 0. Left hand side, the function is x. So when I substitute, here is 0. Then limit when x approach 0 from right hand side. So here is 0. Right hand side, the function is 2x squared. Again, I substitute the value. 2, 0 squared is equals to 0. So since the left hand limit is equals to 0 and the right hand limit is equals to 0, so we can make the conclusion limit when x approach 0 for the function of fx is equals to 0. Since left hand limit and right hand limit are equals. So in the third condition, since f0, where the value is 0, is equals to the limit when x approach 0 for the function of fx. So we'll compare first condition and second condition since they are equals. So fx is not fx but hx. Sorry, here is hx. So here is the hx. Not fx, here is hx. Because the function is h. So here is hx. Sorry, I changed to hx. h0. So here is hx. So here is hx is equal to the limit for the hx when x approach 0. So hx is continuous at x is equals to 0. So for continuity, you have to show these 3 steps or these 3 conditions. So now we move to question B. Find the value of k such that hx is continuous at x is equals to 2. So now it's x is equals to 2. Same, we have to start from the first condition, h2. So 2 is included in the second interval. So the function suppose is 2, 2, squared. So here we should have 2 squared is 4, 4 times 2 is 8. Next, limit when x approach 2 from left hand side for the function of hx. For the function of hx, so here is 2 from left hand side, the function is 2x squared. So here is 2x squared left hand side. So I have substitute 2 squared, again here is 8. Then limit when x approach 2 from right hand side. So this is 2, right hand limit is negative 2x plus k. So it's negative 2x plus k. So substitute 0, negative 2, 0 plus k. So here is 0 plus k is equals to k. Since the question mentioned that find the value of k such that hx is continuous. If the function is continuous, the limit must be exist. If the limit is exist, means that left hand limit must be equals to the right hand limit. Therefore, left hand limit is 8, right hand limit is k. Therefore, k is equals to 8. So this is the second answer for the question example 2b. So there are two types of questions that we can find value of k. Either is using the limit, like example 1, left hand limit and right hand limit. Or in example 2, is stated that it is continuous. If it is continuous, you have to start from the first condition, then the second condition. So you have to start from the first condition, then the second condition. In order to find it, hx is continuous at x is equals to 0, so we have to do these three conditions. First condition, second condition, and here is the third condition. So this is the answer for example